Hi, I'm Ricardo. For those who haven't met, I'm up here in Bibbidi, UK. I'm an engineer and an executive. I work a lot in the cloud and a lot around the Kubernetes space and containerizations and deploying of microservices and all that good joy. And today I'm going to just give you a brief touch on something called open application model, right? So I want to start on first, let's see what the problem is, right? So the first thing we have to think about in application model is we have something like Kubernetes or cloud platforms, which has done a really good job, right, at giving us APIs to manage containerized infrastructure, right? Where we can submit to these things and they run our workloads, right? Our containerized infrastructure, how to run them, their configuration, their ingresses, and sort all of that out, right? So out of that world, right, we now have to deliver workloads or applications to run on these platforms, let's say Kubernetes. And what we see has evolved is an application model, right, for those of you familiar with Kubernetes. So the current application model, right, is roughly consists of, say, a container, right, which is the actual workload, the thing that the engineers are building, right, a microservice or whatever it might be. The workloads, which would be in the Kubernetes world, like a pod, a stateful set, a deployment, a daemon set, which is like how we're going to run this container. The cloud services involved, whether this be like RDSs, databases, networking, configuration, which in the Kubernetes world is like environment variables, config maps, and secrets. And then we have the behavior of these things, which is like horizontal pod auto scaling, the networking, the incoming ingress traffic, all of these things. Then we have another layer, which is packaging. So how do we package this all up? So in the cloud native world, right, we have things like Helm and Customize, right, which is trying to package up all this configuration, whether use base charts in order to deploy this entire set, right? And the deployment then again is pipelines, whether it be GitOps or whatever the incumbent solution is to kind of deliver this working application, right? The entire business offering to run in our cloud native platforms. So given we know this is a current application model, and guys who have worked with this, you know, death by YAML deployments, pods, environments, config map, and all that, we have some limitations, right, that we see come out of this. The first thing that we see is this is difficult for devs, right? Because the view is not really just a developer's point of view. It's not like run my app, right? You know, they have to have other considerations that we saw from the other thing. They have to think about these things. So it's kind of hard to adopt. It's not looking at the workload or the service from an application point of view or developer experience point of view. I like to think about it. We generally glue all these things together in the background with pipelines and imperative pipelines and scripts and all sorts of stuff. So we have all of these things. The other thing to concern is if you look at the current API, we have this like no clear boundaries between like, in a way, between application and infrastructure, or what the application is, how it's going to run, where it's going to run, how it's going to get its traffic. There's really no clear boundary, both from like defining it as well as from an operator, like who's responsible, like should the dev care, should the AppOps team care, should the platform team care, all of that stuff, right? And we also get a friction of ownership, right? The dev wants to deliver the software, the ops team wants to make sure that it's scalable and the resources are there and the traffic patterns are correct. So we have this friction. So we have these current limitations potentially now with the current app model. Just as this slide is just indicating for those of you who've written Kubernetes, this is like minimal YAML, right? So we've got like a highlighted here, like a deployment. So I've just highlighted like a dev might be concerned in the container that he wants to run, whereas the DevOps platform people are concerned with like termination policies and rolling update strategies and other things. They're also concerned with the auto scaling and the ingress and all of this good joy, right? So we have these varying concerns competing in the same definition almost. Also, it's a lot of YAML and a lot of incumbent, I think, a lot to ask from our engineers. Oh, I've got a question here, Duncan. I didn't see it. Duncan's got his hand up. That's fine, I'll continue. So this is like the not my concern approach, right? Who's responsible for what here, right? It's quite difficult and it can get quite hairy quite quickly. Okay, so let's think of maybe there's something better, right? So we need something maybe to extrapolate this away, to think about it differently, to represent it differently, to think about modeling the application separate from the infrastructure, right? We still want it to be like declarative. We want to say what it is, YAML, like this is what I want, right? So it can leverage all the cool features that we already have. We want hopefully like a separation of concerns, like we mentioned, like what the dev wants to do and what the ops or the app ops teams want to do, right? We want to make it so that it's extensible. It's kind of like decoupled, right? So the definition of the application is not coupled to a technology per se. So it's like a definition or a spec. Something goes about realizing that spec. So it's decoupled, runtime agnostic. And we still want to use our current stuff that we know well, right? So we still want to use our DevOps tools, our pipelines, Helm if we still want to use it for other reasons, right? So we want that. So given that, right, an initiative came out called the Open Application Model, right? And I stand on the correction, but it's like between Microsoft and Alibaba Cloud, right? And they went through this and they looked at it and they started on the premise of an open application model. And fundamentally what they came up with is an application, if you thought about it, has components, right? This is the component, the thing I want to run, right? Which is a container, typically, okay? And then that application itself has traits, how it's going to operate, right? Traffic management, blue, green, auto scaling, all of that good joy, right? Then there's the open application model, which is the definition, and then something that implements that model that then can effectively do the translation and do all the grunt work underneath to do it on Azure or Kubernetes and IoT or on-premise or something else, right? So now we've got a definition that's more app-centric, developer-centric, right? As opposed to mix and match that of our current states. And then we have things that implement the open application model to make it real. So we have this open application model. And then if you think about the personas that come after that, right, is we have the devs, which are maybe concerned with the container, the function, and maybe some cloud resources, which are the components, right? And the ops or app ops team or platform team or whatever the name is going to be are concerned with like the traits, traffic management, Kubernetes, blueprints, scaling, right? So we have an application consists of components and traits for those components and scopes. Okay. So one implementation of this now open application model is something called Kubevela. So it is the thing that implements open application, and that is specific to Kubernetes, which I will demo to you now. Going through too many slides. Keyboard mapping. So we're here, and I'm just going to start off with a combined application, and I'll show you in the demo how we get here. So if you remember from our previous slide, we had a ton of YAML, right? We could condense that theoretically down to just that, right? To just what you see on screen now. We're just defining an application. There's a couple of components and traits. That's all we need to do now instead of deployment YAML, ingress YAML, HBA YAML, and a bunch of other stuff that comes from that. So what I'm going to do now is hopefully make more sense of it by actually going through a demo, and hopefully this all works. So I should now be shifting to my Visual Studio Code. Can everyone see that? Can I just get some hands just to say everyone's seeing the Visual Studio Code? Perfect. Let me know. I've got a high-res monitor, so sometimes it looks a bit small for people. But I'm just going to zoom in where applicable. Okay, so I'm just going to start off just by showing a vanilla application when we might want to deploy it to Kubernetes. And I'm not taking into account Helm, base charts, and K-customize. I'm just talking straight up application. Right? So we've got this deployment here. And for those of you familiar, I'm not going to try and explain the K well, but basically we're showing this. We've got a container. We're telling Kubernetes how we want to run it, container ports, cluster policies, everything that comes in that. Then we're defining a horizontal pod auto scaler as well, so we can scale our workload based on CPU. We're supplying the ingress definition, so we keep the traffic coming in. We're supplying the service, so we have that intrinsic service discovery and all of that good joy. And then we might, for example, have monitoring in place. So typically, well, maybe deploy the Prometheus operator, so we have another YAML to register the metric scraping right, that we have going on here. So this is quite a lot, right? So now, if I think back now, let me put my developer hat on. It's quite a lot of stuff, right? Do I care about most of it? Maybe not. Maybe I do, but generally I'm just interested in getting my container out, right? Okay. So now I think to myself, okay, how can I use this in that open application model? Okay? And now let me put my app operator on, or platform builder, whatever you want to label this role as, okay? So I'm going to look here and say, okay, so I want to extrapolate this. Developers don't really care, right, about deployments, right? So what I'm going to see is that we're deploying a microservice here, hypothetically, right? That's what we do. So what I'm going to do is like, okay, let me define or compose or extend a component. Okay. So the first thing I'm going to do with Kubevela is I'm actually going to go here and define what I'm going to call a component, right? So I'm going to define a component here as an apps guy, right? And what I'm going to do here is with Kubevela and OpenAPI, there's three types of ways fundamentally we can define things. We can define a component using something called Q, which is a template. We can define it with straight up Kubernetes manifest primitives, and we can use Helm. But I'm just going to show you the Q stuff because that's how I've implemented it. But you can read the documentation there for the intrinsic details. But all I want to show you is that I'm defining my own custom components from the open application model. And I'm going to call it microservice because I'm bad at naming. And I'm going to say that when somebody asks for a microservice, when they specify component type microservice, I will then take care of creating the deployment in the background for them. This is you start seeing a deployment here, right? I'm going to output a deployment. I'm also going to output the service for them, okay? And I'm going to then allow them to supply some parameters. Obviously, we want them to give me the image, the port, and some environment variables option, right? So what I'm going to do there is I'm going to have that microservice, right? So as an apps operator, obviously, I would not deploy this manually. I'd use GitOps, but effectively what I'm going to do is I've got a cluster already set up for this demo, and it's got Kubevela running and everything in it. So I'm just going to apply templates microservice.yam. Okay, so I'm going to now, just apply this definition into my current cluster. Okay, cool. Right. Fantastic. So we've got now this, okay, and that didn't work because I'm using the wrong path here. So ls demo button not working for me. To control apply -f / what do I want here? I want components. Yes, microservice. Okay, there we go. So I've deployed my microservice, right? Now I can see this. I could control get component definitions. And I've got a word service here. Just ignore these. They like defaults that come with Kubevela. But there's my microservice component type that's available. So I've got the first building block right? So how now putting my engineer hat on, so I normally want a deployment and a service. What would an engineer do now instead of like typically specifying these, right? Well, I'm going to just start with the demo here, and I'm going to cheat sheet my notes quickly. If I can find them. And I'm going to say, okay, I now want an application, right? And now all I'm telling the application model effectively is I've got a component, that's my name, and it's type web service, or actually that route, we're going to make it a microservice. Right, okay. So now let's see what happens if I apply this into the cluster as it stands, right? So I'm going to control apply -f. Let me see what I've got going on here. Directory structure, where am I? 1, 2 examples. Oh, my demo 1 get. And I forgot the apply command. Right. That's all we've done, right? So what has happened here? This has been submitted. The component definition was detected, and my template ran, right? So let's see what I've got now. If I control gets in this namespace, you will see all of a sudden I have a deployment and a service, right? Which would roughly correspond to what I used to have, right? But now I've got, what, 12 lines of YAML, right? And me as the operator, I've gone ahead and I've made sure that whatever I wanted that is by standard or I wanted to hide away is present in this deployment. So deploy, oops, just going to let that for autocomplete, microservice, sorry, YAML. Right, there it all is, created for me, because I defined as the operator what that's going to look like, right? So now I've got all of this done. Engineer just says, I want an application, part of its components is a microservice. I could add more of these components. I could replicate the list if I had another container that would start up, and it would just go through the same cycle. So what I've achieved now is cool, it's extensible because I can create my own type of components, component types that a developer can engineer. I've got a separation of concerns because the developer is just concerned with giving me the image and the ports, right? He doesn't care about anything else. He doesn't really know much about how it's going to happen, right? And I've got like, what I'm concerned as the ops guy, I'm providing all the nitty-gritties in the background that it's not centric for a developer or an application. So I've achieved that. So now we've got a workload in a service, fantastic. So the next step would be, remember, is that's the what is running. We've got the components. Now we've got other things, ingress, specs, all sorts of stuff. So that's a trait that we can attach to a component, right, in Open Application Model. And much the same way, what I'm going to do is, let's see here, I'm going to define a trait definition, right, which is microservice ingress, because again, I'm terrible at names, which is going to input out in this scenario, native to Kubernetes, an ingress resource, right? And again, parameters. And I'm going to do some cool stuff here to indicate the health. And what's going to happen here is I'm also going to allow it, which I haven't done, which is very bad practice, is I can say that this trait could only be attached to certain types of workloads. So I can only attach this trait to a microservice, right? So I've got that control. But I've already deployed these traits into the cluster with kubectl combine. So what I'll do now is, again, so the developer, now putting my developer hat on, comes and says, oh, I want to ingress here. And that's a trait, right? And so we will just add a trait to this workload, if I'm not mistaken. And I'm going to call it, my trait here would be, what did I call this? An ingress. Oops, right. And now the developer is just going to tell me what's his max, what's his min, and his utilization, right? He doesn't need to know about HBAs. All he knows it's, and that's the wrong thing. Oh, give me a second. Here's my notes. I'm taking the wrong notes. Just going to steal this one quickly. Back to my demo. And I should be able to do that instead. Right, that's better. Okay. I'm just going to say the domain and HTTP. You can see here that the trait just says ingress, right? It doesn't mention anything about a Kubernetes ingress. It doesn't mention how it's going to come about, what as a result of this ingress is going to happen, because all the developer or the app-centric approach is saying this app needs an ingress and it needs a domain and an HTTP, right? In this world, if I go ahead and apply this, right, we should now have an ingress object. Good. Right, all of a sudden we have an ingress object, right? I could have added other things to that. I could have made it further configs, custom CRDs. If you're using service meshes, I could have hid it all behind there. But the point is that I've said, well, engineers, if you want ingress, just add a trait, right? We'll take care of how that happens in the background. So the cognitive overhead is easier, and we're looking at it from an application point of view, right? And then, so we've taken care of, back to our vanilla, we've now taken care of what used to be all of this by an engineer, what used to be this, right? What used to be this, okay? And then taking on that model, I've again defined traits for resources, which is CPU bound, memory bound. I've also defined scalars myself, microservice scalars, which then creates opinionated stuff. And then for good measure, what I did is I then installed another specific type of thing into my Kubernetes cluster, which generates Prometheus metrics and alerts. And I've gone and I've hidden that behind what I'm going to call prom metrics, which is going to create a service monitor and an SLOs, right? Which is going to do a bunch of stuff here, but it's going to generate a custom type, which is an operator. For those familiar with it, it's going to land up generating a bunch of metrics for us and alerts just off the bat. Okay, so I deploy all these traits and they become available for consumption, and the final result basically should be something that looks like this, right? So what we got here, reading from the top, my engineer said, well, I want this to be a microservice. Here's my image. I want it to scale. The trait, I want it to have an ingress. Here's the metrics I want. Just tell me where to go get them. And I want some service level objectives here. Just give me some queries. So now I've got 38 lines of YAML. And if everything works accordingly, I'm going to go and save that. Configured, and kube control get deployments, deploy ingresses, services. What else did we got? Service monitors, and I think we're going to have Prometheus metrics out there. If I just add the last one, which I'm going to pull out of here, SLO trait, that, like that. And there we go. We've got the entire application and everything it needs defined now like this. Right. So advantages to this, right? As you've seen, I'm defining the application from an open application model with components and traits, decoupled from the runtime, right? Because components and traits have nothing to do with Kubernetes. As an operator, I'm defining what those traits are, what they will result in. I'm also defining what a component will result in, right? I can have one-to-end components and one-to-end types of traits, right? So I'm starting to build an application model, right, that is developer-centric and for engineers, while maintaining my concerns as an operator or an apps operator around how the thing should need to behave, right? I can change these, I can move them, I can add capability. What we also have here is we don't have complex Helm templating. We don't have complex Helm charts, right? It's extensible quickly because I can add traits as the demand arises. I can add more traits. I can add less traits. I can carry on extending and hide the complexity away, right? Second of all, we get this cool stuff now is Kubevela can also run Terraform. It can also do something called Crossplane, which I'll leave for a different talk. But for example, here I've defined a trait called RDS, right? A component called RDS. And I've defined using Crossplane, which is another tool, which is really awesome, the provisioning of an RDS database on AWS, right? And I've hidden all that information away such that now a developer could come and says, yeah, I need a database for this, right? So as part of what we can do, the developer would all you need to do is add a RDS trait, a component. And we'd say my DB. Now he gets a database along with his application, right? With decoupling, because he's concerned with database. He's not concerned with how the database gets happen. He's concerned with, I need a database. That's what my app needs. And I will, as the operator, take care of all the weirdness behind it, right, to application. So I'm extending this. In the Kubernetes world with Kubevela, this is pretty cool because it's constantly reconciling, right? It's not like Terraform run state, run apply, run state, run apply. As soon as this happens, or as soon as it changes, the state gets reconciled continuously. So if I added this now, or If I remove the trait, that would happen automatically. All right. And fine, and I can't remember which one I removed, but we'll be short a ingress here. Yes, no CPU scan is gone. Yes, horizontal HPA. So the power in this is, again, we've kind of said what is better. We've got an app-centric view. Operators can define stuff that be considered by the engineering teams or the application developers to use. It's decoupled, it's extensible, it's still agnostic of the runtime. In this case, kubevela is the runtime. Kubernetes is under the hood, and kubevela is translating that. But you could use an open application model and translate microservice to a Lambda function, or translate it to an EC2, because the open application model definition is independent of the runtime. It's extendable, as you've seen. I'm just adding stuff as we go along. And it can still be used by normal workflows, right? I could still maybe wrap up applications in Helm. I could distribute them. I could use GitOps to deploy them in Argo, and all of that good stuff still remains together in one component. So I've got like this app-centric view, which is what we were after, making engineers' life easier while making my life easier to help the engineers build stuff without hanging themselves, technically. So that's pretty much my demo. I know maybe it required prerequisite knowledge, but I hope you kind of see where this is valuable maybe in your teams, especially when you need your engineers to move without being incumbent upon prerequisite knowledge of the thing they're running on. Awesome. So that's my demo. I hope it made sense. I encourage you to go read about it, because there's many more features inside of this that you can tweak. You can run Terraform, Crossplane. You can extrapolate a lot of stuff to build out your application model. Read about Q and the various ways to do things, which are kubevela implementation. Just kubevela.io. Welcome to go read about it. There's lots of talks in it. It's a really cool project. It's got 1.0 GA, so it's theoretically usable in production at the moment.